section 10.2. Now, before I go over these sections, let me go over one simple example. If you recall in algebra, when we give you coordinates of 2 points, and we ask you to find equation of the line, find equation of a line going through 2 points. So when we give you 2 points and ask you to find the equation of the line that goes through these, what we normally do is first we find the slope. We take one of these points, you call it x1 and y1, and the second one is x2, y2. We find the slope, and then when we find the slope, we put it into these equations, and then we find the equations. This was equation of a straight line. So it's the linear equation, because linear equation means you have straight line. The graph is straight line, okay? Now, in section 10.2, when we give you a bunch of points and we ask you to find the equations, equation that you find in section 10.2 is equation of this straight line, and they call it regression equations. And for that, we use this formula, y equal b naught plus b1x is the equation of the straight line, or a line that goes through all the points. Now, b1 and bo, they all have their own formulas. So if you in the table in back of the stat book, which I also have a copy of that on MATLAB, see this table? Correlations. On that one, this is the equations, BO plus B1X. And each of these, like, look, B1, you need to find sum of X, sum of Y, sum of XY, sum of X2, sum of X. And BO has all these calculations. When you find all this, then you plug into this formula. So for chapter 10, this is these two formula, we already use this for chapter 10.1. For 10.2, we are using regression equations or regression line, and this is for 10.3. But for this one, it's easier to use a calculator. A calculator would do BO and B1 for you, so you don't have to go through all this. But I just want to show you, if you want to do hand calculation, this is how to do it. It means you have to find B1 and BO not separately and then plug into these equations. So instead of having Y is mx plus b or b plus mx, here they just show Y hat equal. It's just a difference letters we are using, but it's the same thing, it's equation of a straight line. And this is how to use TI-84 to find it. I'll show you. And then they're telling you that when you find your R value, if the R value is strong, you go through this route. If R value is not good, then you cannot find it. What they're saying is this, you know, if in these equations, when you find the equations, if you come up with a good correlations, if the correlation is good, like this, if we give you a graph and you have a good correlations, when you have a good correlations, then you're able to find equations, right? And then when you find the equation, then if we give you a value of x, how do you find the y value? Let's say x is 10. How do you find the y value? You just take that and plug it into this formula, okay? But what if you have some points, you plot some points, and they don't have a good correlations? When they don't have a good correlations and you have the equations, you cannot use the equation because you cannot create a straight line here. So in that case, we give you a bunch, you have a bunch of x and a bunch of y, right? That's how you came up with these points. If we come up with a number, let's say x equals 7, what's the value of y? If you don't allow to use regression equation because you don't have a good correlation, because like r equal to 0.1, if you don't have a good correlations and you don't have the equations, then how would I find the y value? In that case, what they are telling you is if you have an x like x equals 7, or let's say x equals 10, or x equals any number, if we ask you to find the y value, what you could do, you could take the average of all the y's. Take the average of all the y's and use that, okay? So if you have a good correlation, let's say you have a good correlation here, and we give you x value and ask you to find, you just plug it in. If you don't have good correlations, you cannot use the regression. Even you see it, you cannot use it. But what you can do, you could take the average of all the y. So that's what we're discussing here in this section. This is what they're discussing here. They say, yes, regression equation is a good model. No, regression equation is not a good model. When it's not good model, regardless of the value of x, the best value of y is the average of all the y's. Here they are saying, no, you could go ahead and take that x and plug into regression equations. Then I'll show you an example here, and this is the solutions. What we did, we use our calculator. I put all this one in L1 and L2. When I did that, calculator give me regression equation directly. So I don't have to use the A naught and B naught separately. You just give it directly from calculator. And then all I need to do, whether to see if that R value from the calculator is a good one or not, I compare with table A5. Table A5, I find the R value. As long as R of calculations is greater than R of table A5, then we have a correlations. Since we have a correlations, we have a good correlation, then on the second part, they are saying X is 63. What's the Y value? Then you could go ahead and use the formula. This is another example. You have a pair. These are X's, these are Y value, okay? Again, what you do is you go ahead and use your calculator. You go to linear regressions, and when you do that, you find your equations. When you find your equations, first you have to check your R. R from the calculations, from the calculator was 0.978. It has to be greater than R from the table A5. Table A5, in this problem, there were 6 values and alpha was 0.05. So it's 0.81. As long as our number is greater than this, which it is, then we have a good correlation, okay? This is a case that your, all the numbers is given. You don't have to do any calculation. We already have all the numbers. All we are asking is, okay, X is 5. Find the Y value. They're asking you to find the Y value when X is 5. Do not, although they give you the equation, this is regression equation, do not use it. Why not? First, check to see if the R value given the problems is greater than table A5 or not. Is not. From the table A5, this is what we have, right? 0.361 means your number must be greater than this. But look, the R value they're giving you is not greater than that. And also the p-value. The p-value that given in the problem is 0.134. That one is less than the alpha that is given in the problems. For these two reasons, you don't have a good correlations, okay? See here? When you don't have a good correlations, what should I do? If I have an X, how could I find a Y? Find the mean of Y, which is given in the problems, 6. So use average of all the means, which is given in the problems. All right. So again, if you do not have a good correlation, do not use regression equation. Even though you see it, you cannot use it because you don't have a good correlation. In that case, for any value of X, it doesn't matter whether it's 5 or any other number, for any value of X, always take average of all the Y and use that. And just say, okay, if X is 5, Y equal to that. Okay, now here they're talking about outliers and influential points. I don't think so we have any homework from this, but just to let you know about these sections, I think I have a better picture here for you. So what they're saying is, you know, when you graph a scatter plot, when you have all the X and Y and you plot those, there might be an outlier. What is outlier? Outlier is a point lying far away from the other data points. Pair sample data may include one or more influential points, which are points. What is influential points? Which are points that strongly affect the graph of regression lines. So you need to identify if there is any X value which is extremely large or small compared to the rest of the values. Okay, so here they show you here. In these pictures, numbers are okay, you know, there are some which kind of far, but what they do, they just add a very large number to the data, X50 and Y0, which is a number here, look. What happens is when they start graphing, the graph, rather than be like this, it dropped to this. See, one influential point is a large number that is far from all other numbers. What happens is if you just add 1 point, such as this, the graph completely change. Line change dramatically change to this. Okay. So for that, they're asking you to find a residual method. And what it is, residual method is, they're saying that the number that the observed value you have, you have to subtract predicted value from that and use this as a Y. I'll show you on the examples here. You know, we have this example. 4 X's are given and 4 Y are given. X is 8, Y is 4, X is 12, Y is 24, X is 20, Y is 8, X is 24, and Y is 32. Equation of the line, equation of this line is given. Equation of the line is Y equal 1 plus X. Now, I'll take this X equal 8 and substitute here. When you put X equal 8 into these equations, the value of Y is 9, is not 4 anymore. When you take this X equal 8 and you put it in the equations, Y plus, 1 plus X, the value change. The value is not 4, is 9. What is the difference of these two? The difference of the first one minus the second one, the difference of these two is -5, right? You have to do that for every number. Like you take the 12 and you substitute the equation, see what number you come up, change it from 24. So when you do that, see, I'll show you all the calculation here. Like for 12, For 12 here, you take the 12 and you substitute for the x. What's the y value? 13. Okay. Then you take this 13, subtract from the one that is given in the table is 11, and so on. Now, when you find these numbers, you create a square. Like this is 11, right? Then you generate a square by size of 11 by 11. This 11, which is a difference of these two, is called residual. So residual is the difference between the one that's given in the problems and the one that you actually calculate through the equations. And here it said, you know, and then you find, you take all this, what's the area of the square? Like 11 times 11. What's the area of this square? 5 times 5, 13 by 13, right? You find the area of all this and then add together. So I said we could visualize the least square property by referring to this figure, where the square of the residence represented by shaded square area. So at the end, what you do in this case, when you want to graph, for the x that you're using 8, 12, 20, 24. You had this value for the x, right? For the y value, do not use these numbers anymore. Do not use these numbers for y anymore. What you need to do for the y, you have to use y minus y bar. Okay? Which is what? Which is -5 here. You see that 11? 11 here. For 20, use -13. For 24, use 7. That's what they're asking you. They say graph, but using this as an x and this as a y. That's what is called an inflationary point. Now, here at the end, I also put an example here. And you see this problem has everything because, you know, I put the solution here. But I want to go through this solution in a better way so you understand it for these problems. In these problems, what they want us to do, they want us to use this as L1, this is L2, okay? Look, here. There are 3 lines are given, but they want us to use shoe print versus height. They don't want us to use the middle one, just the first line and the second line. So the first line is L1 and the second line is L2. So what I did already, I go to a stat and I input those numbers already. See how the first number is 30.3, 29.8 is these numbers. And the second row is 179.9 stuff. So you put all the numbers in L1 and L2, all right? Now, when you do that, then you go to stat, test. You scroll down all the way to this one, F, linear regression t-test. Calculator already has everything. You don't have to change anything. Just make sure this one is not equal. You remember rule R is not equal to 0, so you always use this one. Because you just say whether it's a correlation or not. Calculate. What you have is this here. I'll show you on the next page. A calculator would give you R. Okay, let's get these numbers first. Look, T is 0.33, which is a T here. I'll show you later on what is this formula, but that's the T we get from there. The p-value is 0.75. That's the number here, p-value 0.75. A and B are the number that we normally use for regression equations. Remember, the regression equation is this. Calculator, instead of A naughts and B naught or B1 stuff like that, calculator you just use A plus BX. Okay, it's the same thing. So we don't need A and B. Why? Because the calculator will give you the R value. R value is 0.191. So R from the calculator is 0.191. Okay, and T is 0.337. And P value is that. So these are the numbers that you extract from the calculator. All right. Now, I have the P value, I have an R value from the calculator. This R must be greater than R that you find through table A5. On table A5, if n is 5, because there is 5 pair, right? And alpha is given is 0.01, 5 and 0.01 give you that 0.959. Your number must be greater than this, but it's not, it's smaller. If your number is smaller than this, means there is no correlation. So for us to have a correlations, our number must always be greater than that. These are the minimum numbers. So yours must always be greater than this. If not, then there is no correlations. Also, the p-value we calculated is greater than significance level. If the p-value is greater than significance level, which is alpha, then there is no correlation. See, the second proof that you don't have any correlation. Now, what's the third proof that you don't have any correlations? You know, you find the T through the calculator, and if you want to do the hand calculations, you still come up with these numbers. So the calculator is just to verify that number, right? So let's say we ask you to show the calculations, hand calculations. So you just write this formula. You have R, you have N, you plug it in, and you should come up with this value, and calculator will verify that. Now, graph. You go to table A3. Table A3. And for DF, we don't use n-1 anymore. In this case, for section 10.2, we are using n-2. So you go to this table, T distributions, and DF is 3. You find the 3 here. And area in 2 tails is 0.01. See? Because we have 2 tails. It's 5.841. 5.841. That's the number that you have on the graph, positive and negative. Our T value fall into the good area, not in the critical. That means we accept HO. And we reject H1. And H1 is a claim that there is a correlation. Again, no correlation. So 3 methods to show that you don't have any correlation. So that's what we do on section 10.2. We just discuss about regression equation.